Welcome to the IDEX Laboratories ELISA training video. The goal of this video is to introduce you to ELISA technology, discuss the materials necessary for testing, and review the procedure to perform an assay using an IDEX ELISA test kit. ELISA is a rapid test used for detecting and quantifying antibody or antigen against viruses, bacteria, and other materials. This method can be used to detect many infectious agents affecting poultry, swine, and ruminants. There are a variety of materials that you will need for ELISA testing. All of the reagents needed for testing are included in the test kit. Additionally, you will need pipettes, a washer system, and an ELISA plate reader. The ELISA test kit is a set of standardized reagents and microwell plates manufactured for a specific test. IDEX ELISA test kits contain some or all of the following components: coated plates, sample diluent, controls, wash concentrate, conjugate, substrate, and stop solution. The kits are manufactured in batches or lots to work as a unit. To ensure accuracy of results, never mix or use components from different kit lot numbers. The 96 well plates are made of polystyrene and are coated with either an activated antigen or antibody. The function of the plate is to hold the immobilized either antigen or antibody. Antigen or antibody present in the samples will bind to the plate. This coating is the binding site for the antibodies or antigens in the sample. Negative and positive control are provided with each kit. The controls help normalize or standardize each plate. Controls are also used to validate the assay and to calculate sample results. In most but not all kits, the controls are pre-diluted and ready to use. Be sure to refer to the kit insert for specific instructions. ELISA conjugates are enzyme-labeled antibodies that react specifically to plate-bound sample analytes. Unbound conjugate is washed away after incubation and before the addition of substrate. The wash concentrate is a buffered solution containing detergent used to wash unbound material from the plate. Not all test kits have wash concentrate. Some assays will require distilled water for washing. Be sure to refer to the kit insert for specific instruction. The stop solution stops the enzyme-substrate reaction and color development. Equipment for ELISA testing is widely available. Readers, washers, and pipettes are available as manual or automated systems. One of the main factors affecting equipment selection is the number and types of tests and samples being run. To run the IDEX ELISA test kits, your reader will need to have a 650 nanometer and a 450 nanometer filter. Pipettes are available in both fixed and adjustable volumes, as well as single-channel and multi-channel. Washing systems can be manual systems that wash one row or column at a time, semi-automated systems that wash one strip or plate at a time, and fully automated systems that can process multiple plates. The maintenance and calibration of your laboratory equipment are extremely important in obtaining accurate and reproducible results. Equipment that is not calibrated or properly maintained can produce false or inaccurate results. How often you perform calibration or maintenance procedures will depend on the volume of testing you are doing in your laboratory. Always refer to your equipment manufacturer's guide for their recommendations. Keep good records of your maintenance and calibration schedule. In addition to keeping records on equipment maintenance and calibration, we recommend that you track information on your ELISA kits as well. Keep records of when kits are received and used. To properly manage your kit inventory, use the oldest kits first. It is also a good idea to record the lot number of the kit with test results. Getting ready to run an assay. Prior to running your ELISA test kit, reagents and plates should be brought to room temperature. In order to avoid freezing the kits, Make sure they do not come in contact with the wall of the refrigerator. During kit warm-up, remove the kit components from the box and allow them to warm up at least 2 hours before beginning the assay. Allow plates to warm up in their sealed bag with desiccants. Measure out the correct amount of reagents for the number of tests you're running. Do not return reagents to the original stock bottles. We strongly recommend that you use disposable pipettes and reagent reservoirs to minimize the risk of contamination. If you choose to reuse reagent reservoirs, be sure to label them so they are only used for one reagent. Never use the same reservoir for conjugate and substrate. Thoroughly wash reagent reservoirs after each use and change them as frequently as possible. ELISA tests are sensitive to temperature extremes. Try to maintain a laboratory temperature of 20 to 25 degrees centigrade or 68 to 77 Fahrenheit. Avoid running assays under or near air vents or in direct sunlight. Record and track the temperature of the laboratory during each assay. If you have temperature conditions that are difficult to control, it may be a good idea to use a temperature control chamber to incubate your plates. The quality of your samples can have a significant impact on the final assay results. Unfortunately, most labs have no control over the quality of incoming samples. Obtain a fresh sample. Serum samples with trace hemolysis and moderate lipemia may have little or no effect on ELISA results. Avoid using samples that are heavily hemolyzed or grossly lipemic. Check your package insert for information. Be sure samples are properly stored. In general, serum samples should be refrigerated 2 to 4 degrees centigrade for no more than 3 to 5 days. If samples need to be stored for a longer period, they should be removed from the clot and frozen at a minimum of -20 degrees centigrade. Frozen samples can be thawed at room temperature or in a refrigerator. All thawed samples need to be thoroughly mixed prior to dilution to ensure that the proteins are dispersed throughout the samples. Mix samples by gentle vortexing or inverting at least 5 times. Careful pipetting is crucial for accurate test results. Familiarize yourself with proper use of your pipettes prior to running actual tests. Be sure to use correct pipette and tip for the volume being transferred. 2 types of pipetting methods used for ELISA testing are standard, forward, and reverse. Use standard pipetting for the preparation of sample dilutions and reverse pipetting for addition of reagents. Standard, forward, pipetting. Put a new tip on your pipette and make sure it's on tight. Press the plunger to the first stop. Some manufacturers recommend that you pre-wet the tip by aspirating and expelling an amount of sample. Draw the appropriate volume of sample into the tip. Touch the tip to the side of the sample container to remove any excess liquid on the outside of the tip. Dispense the samples into the measured diluent by depressing the plunger past the first stop to the second stop. For samples less than or equal to 10 microliters, after dispensing the sample into the diluent, rinse the pipette tip in the diluent by pushing the plunger down 2 to 3 times before ejecting the tip. Samples can be mixed with a multi-channel pipette when they are being pipetted onto the plate. Reverse pipetting using a multi-channel pipette. Put new tips on the pipette. Make sure they're on tight. Press the plunger past the first stop and halfway to the second stop. Draw the liquid in slowly, being careful that no air bubbles are drawn into the tip. Check the consistency of volume in the tips. Touch the tips to the edge of the reagent reservoir to remove any excess liquid on the outside to the tips. If the wells on your plate are empty, position the tips in the lower corner of the wells, making contact with the plastic. If the wells on your plate contain liquid, position the tips above the liquid, making contact with the plastic. Slowly dispense the liquid into the wells by depressing the plunger to the first tub. Liquid will remain in the tips. To repeat, hold the plunger at the first tub and continue with step 3. Note: reverse pipetting uses more reagent volume. Running an assay. Now that we have reviewed ELISA technology along with all of the material needed and proper pipetting technique, it is time to run an ELISA assay. First, we will demonstrate running an IBD ELISA. IBD is a good example of most poultry ELISA test kits. When running an ELISA assay, it is important to always refer to the specific kit insert. This will give you detailed information about sample dilution, reagent preparation, and incubation times. Dilute 1 microliter of sample with 500 microliters of diluent, or 2 microliters of sample with 1000 microliters of sample diluent. Diluent can be transferred into dilution tubes with a multi-channel pipette. Prepare samples by making a 1 to 500 dilution with sample diluent. Be sure to change tips between the dilution of each sample. Using the standard pipetting technique, transfer 100 microliters of undiluted negative into wells A1 and A2. Repeat the same procedure to pipette 100 microliters of undiluted positive control into wells A3 and A4. Using a multi-channel pipette, mix the diluted samples by pushing the plunger up and down 3 to 6 times. After mixing, transfer 100 microliters of the diluted samples to the antigen-coated plate. Position the tips into the lower corner of the wells, making contact with the plastic. Continue to mix your samples and transfer them to the antigen-coated plate as quickly as possible. It is important to minimize the time difference between the addition of the first and last samples of the plate. Remember to change pipette tips in between each set of samples. Incubation times for the plates should be timed as precisely as possible. After samples and controls have been added to the plate, set a timer for the appropriate incubation time. For IBD, this will be 30 minutes. When running multiple plates, keep your batch sizes small so your processes do not overlap. Avoid washing a plate while another needs to have conjugate added. Allow adequate time between plates and set a timer for each one. After samples and controls have incubated on the plate for 30 minutes, wash the plate with approximately 350 microliters of distilled water. Plates should be washed 3 to 5 times. The number of washes may depend on what type of wash system you are using. A more manual wash system may require more washes than an automated system. Wash plates 4 times and make adjustments if negative controls have high background. For consistency, always wash plates with the same number of washes. For this demonstration, we will wash our plates with a manual wash system. Begin by aspirating the reagents from the plate. Make sure that you aspirate all of the liquid from the wells by placing the aspiration needles at the bottom and in each corner of the wells. After the first row of wells is empty, dispense the wash solution. Make sure to fill the well completely, but do not overflow the plate. Continue with the first wash on each row of the plate before moving on to the second wash. This will prevent the wash from drying out while the plate is being washed. After the final wash, aspirate the wash solution from the entire plate. Tap out any remaining liquid onto several layers of absorbent material. After tapping out the plates, check the absorbent material for any evidence of color. This may indicate that the plates were not washed properly and there are reagents remaining in or around the wells. Using your multi-channel pipette and the reverse pipetting technique, add 100 microliters of conjugate to each well. Position the tips into the lower corner of the wells, making contact with the plastic. Incubate for 30 minutes at room temperature. At the end of the 30-minute incubation, repeat the washing step. Using the same pipetting technique that you did for the conjugate pipette substrate onto your plate, incubate for 15 minutes at room temperature. After the 15-minute incubation, add 100 microliters of stop solution to the plate in the same order as substrate was added. Because the wells in the plate contain liquid, position the tips above the liquid and make contact with the plastic. In this indirect format of ELISA, the sample antibody is sandwiched between the antigen coded on the plate and conjugate. The addition of the substrate causes color to develop. The color is directly proportional to the amount of antibody bound to the plate. The more antibodies present in the samples, the stronger the color development in the test. In the blocking or competitive format, the antibodies from the samples compete with or block the enzyme labeled antibodies in the conjugate. The color is inversely proportional to the amount of antibody present in the sample. The more antibodies present in the sample, the less color development in the test well. The last step of the ELISA is to read the plate. The optical density of the solution in the plate is read with a spectrophotometer, commonly known as plate reader. The plate reader is operated under computer control with help of the X-Check software. Refer to the package insert for the proper wavelength. Plates should be read as soon as possible following the addition of stop solution. PRRS and verification kits, IBR, BLV, PRV. Next, we would like to demonstrate the procedure for running PRRS and the verification assays. Always refer to your kit insert for specific instructions on sample dilutions, incubation times, and reagent preparation. What makes PRRS and the verification assays different from most other assays is the presence of the normal host cell well. PRRS and the verification plates require 2 wells to be run for each sample. One well is coated with virus antigen and the other well is coated with NHC antigens. The NHC antigens are used to assess whether immunoglobulins against culture components are contributing to test results. ELISA testing, if performed correctly, can yield reliable results and important information on many infectious agents affecting poultry and livestock. We hope this video has been informative and provided you with the necessary information needed to successfully perform ELISA testing. Thank you for buying IDEX, Innovators in Diagnostics. If you need additional information on technique with our ELISA products, please contact our technical services departments in the USA, Europe, Latin America, Taiwan, and China.